Hello there, Math 133 students. In this video, I'm going to give you some hints and help for the Chapter 7 project, Our Home Run Distance is Normal. All right, so let's look at this project here. I have to close some previous video info. All right, so we're going to open the Google document at this link. We're going to make a copy, all the usual stuff. We haven't seen this in a while, I know. All right, so we've got this project. We're logged in, of course, to our Google account in the top right corner. We're in Chrome and in our Google account. All right, so we are going to click File, and we're going to make a copy. And again, I would recommend, as I have in the past, that you put your name up here in the file name. It can really help your instructors. And then you click Make a Copy. All right, so we have our copy. Let me make this a larger zoom in so you can see it if you're watching on your phone. All right, so we have the Home Run 2019 data set is StatCrunch is available here. You're only going to use the distance column, so you can ignore everything else. All right, so here it is. Ta-da. So we're only going to look at this distance column right here. We're going to answer the following questions, or the questions in the boxes. After completion, submit either by URL and change access so anyone with the link is a viewer, or PDF, so we PDF upload. No problem, we've done that before. All right, so we're going to begin by drawing a frequency histogram of the home run distances. We're going to select a bin's start value of 250 and a width of 20. You're going to paste the histogram here, and you're going to comment on its shape. Is it skewed left? Is it skewed right? All right, so I don't think I'm actually going to do this. I'm just going to show you how. So you go to Graph, Histogram, and let's follow those instructions. It said frequency histogram. It said select a bin start value of 250 and a width of 20. Okay, so I'm going to go down here and I'm going to click on distance right there. I'd make it start bins right here. Bins start at 250 and a width of 20. And then you would say compute. But I'm not going to because I'm doing a different one. So I don't want to do it for you. So I want you guys to do it. So click on that, make a graph, and then you'll copy and paste that graph and talk about what shape it is. All right, next, for number 2, you're going to determine the population mean, population standard deviation, and population size for the home run distances. Okay, so you'd have your graph, so you can close your graph. That is stat, summary stat, columns, right? We just did that on the midterm. So stat, summary stat, columns. You click distance. Now you need the mean. This is the population mean this time because this is a population. But because it's a population standard deviation, you have to scroll down and get the unadjusted standard deviation because it's a population value. So control click or command click if you're on a Mac on the unadjusted standard deviation. And then the size is here. It's the N. And again, StatCrunch doesn't really know that this is a population, but it is. So you would click on those 3 values, mean, unadjusted standard deviation, and N, and you'd click compute, and you'd get a table with those answers that you would copy and paste right into here. Lovely. Okay, so now you're going to draw the normal curve with a mean and standard deviation found in part 2 on top of the frequency histogram from part 1. Do this by selecting the overlay distribution and choosing normal and using the mean and standard deviation value found in part 2. Okay, so this is confusing. There's a lot of instructions here. So here's what I'm going to do. I'm going to show this to you, but not with your data set. I'm going to do it with a different data set. It's the home runs from 2013. So it'll be similar, but not the same. Okay, so I would make a histogram. Oh, actually, first let me find those values. So stat, summary stat, columns. I'm going to click on distance, and I would select mean, unadjusted standard deviation, and N. Okay, so I say compute, and then I get some values. Again, these will not be the values for you. I'm doing an older one. Okay, so I've got my mean and my standard deviation. They should be pretty similar, I bet, but not the same. All right, so mean, unadjusted standard deviation, and N. And I'm going to go to a histogram. This is the hardest part. Graph, histogram. And we have to follow all those instructions. So we click distance. You still need it to be frequency. you need it to be that your bins start at 250 and have a width of 20, because those were the instructions before, right? It says bin start value of 250 and a width of 20. You want to collect value above the bar, and you want to click normal. Oh, so many things. All right, so we're going to, right here where it says display distribution, we're going to overlay the distribution of the normal distribution. We're going to type the mean, which in my case is 396.6, and the standard deviation, which is 24.4. Again, I'm using my values. You would pick your values from your problem. And then you click value above bar, and you check that little box right there. Now let's make sure we have all the instructions. Select overlay distribution, choosing normal, use the mean and standard deviation found in part 2, done. We selected value above bar, done. We select a bin start value of 250 and a width of 20. Beautiful. Marvelous, wonderful. So we click compute. Now, it often happens that the numbers are hiding. So I can see this 121 right here and this 525 right here. If you let your cursor hover, it'll tell you how tall that bar is. But you might just want to make the bars bigger, right? If you drag your graph so that it's larger, then you can copy that graph with all those numbers. Copy the image, right? So you might have to make it bigger so you can see all the numbers, and paste it. So I lied a little bit when I say don't resize it. What I mean by that is leave it as a really big picture, but you want to be able to see all the numbers over all your bars. Okay, so then, do you think your normal model does a good job? So look at that red curve. So it's basically saying, hey, does that red curve do a pretty good job of matching that blue histogram? And you can just talk about it, right? Explain what you think. So yes, I think it's doing good, or no, I think it could be better, blah, blah, blah. So just talk about it. Then, part 4, find the relative frequency with which a home run distance between 350 and 389.9 is observed. Now, the relative frequency means a decimal. So, you're going to use the histogram part, the blue part. So 350 is right here, right? It's the, oh, here, I gotta get out of that. That's that bar right there. That's 350. And if you let your cursor hover over it, it tells you. It goes from 350, and it's a little hard to see, but that 370 has a parentheses. What that means is this 350 to 369.9999999. Right? So that bar is one of them. And I think it wants us to go more. Yeah, 389. So that would be those two bars. So you're going to take the 525 and the 1159, which won't be those are not the values for you, but whatever values you get, you're going to put them together. So for me, it would be 525 plus 1159. So I would take 525 plus 1159, and I would get a number. And then I would take that number, whatever that is, and I would divide it by the total. This is why I had you find the n. Okay, so let's open Desmos, and now I have to remember the numbers. 525 and 1159. So I would take 525 plus 1159, and I would get 1684. Okay, so I have 1684. So to make it, that's the frequency now. To make it the relative frequency, we have to divide. So let me just label this. This is frequency right here. To do relative frequency, we divide. So we take 1684 and we divide it by the total, which in our case would be 1684 divided by, and then the total for me will be 4661. It'll be whatever it is for your particular data set. It will not be the same numbers. At least it shouldn't be. And then we would get that decimal. So let me go get it. So 1684 divided by 4461, and I get 0.3775. There we go. So that's my result. All right, so I did part A. So now it says use the normal model. Well, that's that red curve. So let me clear this. So the red curve is the curve that has a mean of 396.6 and a standard deviation of 24.4. So I can do that with stat calculators, sorry, normal. So I'm going to grab that, and then I'm going to say, look, my mean is 396.6 for me, and 24.4. Again, these values will be different for you. They should be pretty similar, but they'll be different. And now we want to change it to be between, because we don't want a single, and we want to go 350 to 390, I believe. Let me check that. Yeah, 350 to 390. So we would put those values in right here and say compute, and there we have it. That's the equivalent of those two pink bars, but under the red curve. Now, it says in here, you can't just write the number. You have to copy and paste the chart with the probability. So you got to follow those instructions. Options, copy. It should give you a picture with the probability at the bottom. Copy the image, right click and copy the image. Go in here and paste the image. You should be able to see that whole graph with those values and the probabilities. And then C is a compare and contrast. It's just saying, hey, look at the answers. Were they close? Were they not close? Talk about it. Talk about the difference that you're seeing. And why might that difference be happening? Or talk about how close they are, right? Feel free. All right, so then I'm going to let you guys do 5. It's the same idea, but this time it's exceeds. It's more than, right? So more than 430. So you do that with the relative frequency. That's the histogram method. And then you do it again with the normal model. Now keep in mind, a more than would not be a between. A more than would be a standard. And you have to switch this direction so that it's greater than, right? So you'll put a greater than on that. And then you'll get a new graph and then compare and contrast those values. Were they similar? Were they not similar? What do you think? Okay, now down here. Which type of model, using the blue histogram versus the red normal curve, do you think is more appropriate for analyzing the particular home runs in just that year? So if you're just trying to look at 2019, which one's better? Which one's easier? Which one's more appropriate? Just talk about what you think, right? Which one did you like using better? Now, if you were going to infer about home runs from year to year, right, in other years, which one's more appropriate? Okay, so which one is really talking about the present, that particular year of 2019, and which one's really talking about all home runs? There's my hint to you. Okay, because I'll give you another hint. One of these is one of them, and one of these is the other. So one of them is really talking about that year, and one of them is really a model that you use to describe and infer for future years. All right. And then just talk about why you think so. So give a little explanation, and you're done. All right, so then you'll click Share. Make it so that anyone with the link can view. Copy the link. And then go to the project. I have to change to a student view, sorry. And then you're going to upload your web URL. So you'll click Web URL, and you'll paste your link. Wait a second for it to say Submit, and then click Submit. And huzzah, we have confetti. The other way to do it is to submit a PDF. So to print or save as a PDF and upload the PDF. All right, I hope that helps.